Hello there, it is KP the Math G. I'm sorry it took me a little while to get started here. I just wanted to make sure that the board was focused in and everything, so sometimes you have to bear with me when I start something. Anyway, we are dealing with integration by substitution. We have several methods of integration, and this is just one of several. Okay, and we're probably going to do this in about 2 or 3 parts. So really and truly, we are dealing with, I guess what we can say, part 1. We are just going to call this part 1. Yeah, so I mean, it's just going to take more than just one lesson to get all the nuances of this idea of integration by substitution. And we are actually integrating the indefinite integral for now. When we do the definite integral by substitution, it is going to be a different setup. It's done. I have a method that we can do it a little differently, and it will be easier for you. All right, let's dive in. I just want to look at a few examples. I'm thinking about doing 3 examples. So let's see how this works. We're just going to say x times the square root of 4x squared plus 9 dx. Okay. How do I know when this is done by substitution? How do I know when to do this method, use this method? Well, when I'm looking at multiplication or division, and I see this exponent is 1 on the outside, and this on the inside is 1 more than that, which is 2. And, or whatever, 2 and 3, 3 and 4, and so on like that. Okay. I'm going to rewrite this problem. Alright. Alright, now remember, this is an index of 2 and this is an exponent of 1. So 4 squared plus 9. Alright, dx. Alright. We're always going to let u, as we're substituting in place of x, we're always going to let u be something here. Alright? We're going to say let u be equal to, okay, this expression that has the bigger exponent. And I'm going to show you what happens here. 4x squared plus 9. Probably, maybe not the best first example, but we're going to go with it. I think it'll be okay. The derivative of u, the derivative of the left side is just du, and the derivative of this side is 8x, and that's it. Now look, here we have 8x, here we have x. I can get rid of this 8. If I got rid of this, well, let's just say dx here. Alright, I have x dx. I can get that. If I can get that just by itself, I'll be alright. Well, if I either divide by 8 or multiply by 1/8, either way I'll do that. So let's multiply by 1/8 on both sides. Okay, then the 8s will divide out. Okay, do you see that? And we are left with 1/8 du is equal to x dx. Alright, so let's substitute, we have to put the 1/8 on the outside of this problem. Alright, so let's do that. Oh, excuse me. So 1/8. Alright. Now we said that this is, okay, this part right here is du. Alright. Alright, so let's see. This part right here is du. And this part right here is u. Alright, so u to the 1/2. Look at this again. Let's let u be all of this. Alright, so u is to the 1/2. du is x dx. We have the 1/8 out on the outside. Alright, there it is. And I can easily integrate this. So this is 1/8. Box it in. U. Now remember, add 1 to 1/2, so u to the 1/2 plus 1, which is again 2/2. Right? Always pick that same denominator. If I'd been a 1/3, I would have made this 3/3. If I'd been a 1/4, I would have made this 4/4. I'm adding 1, so this is 3/2. Now remember, we can flip over. I'm going to move this over a little bit, give it a little more breathing room here. Okay. Flip this over. Remember, if we put it down in the denominator, it's 3/2, but flip back over, it's 2/3. Okay. And then all this, and we're going to put the plus c right here. Alright. We can divide this out. 2 and 8. 1 and 4. So now this is 1 over 1 times 1 is 1. 4 times 3 is 12. U to the 3/2 plus c. But now we don't want to keep it in terms of u. We want it back to what u was. U is 4x squared plus 9. So now we're saying then this is 1/12. 1 over 12. U, which is 4x squared plus 9. Alright, to the 3/2 plus c. And there's your first integration by substitution. You have to realize that if I take the derivative of this, I can get, even though this is 8 here, I can actually multiply and get rid of that 8 and make that 1/8 on both sides here. Okay, and then the 8 is gone here, so that leaves me with x dx. There it is, x dx right there. And u is this, but u is to the 1/2 power. Alright, so I did it. 1/8 u to the 1/2 du, that's this x dx. So everything is covered. Alright, so let's turn it over and let's do another problem. Let's see, I may have enough time to do 3 examples. I don't know if this will, supposed to have magnets on the back. Hey, it held this time. Alright, let's do another one right here. Example 2. Alright, we're going to go with 5x to the 4th minus 2 raised to the 6th x cubed dx. Now guys and girls, now maybe we can apply this binomial theorem and expand the fire out of this, multiplying this by itself 6 times. Okay, and then multiplying that result by x to the third and have a whole bunch of constants and everything. I mean, whole bunch of terms, okay? And I'll tell you what, I'm not doing that. So substitution is far easier than trying to figure out what this is. Alright, so let's go ahead. Look, here, oh, a 4 and a 3. Substitution. Simple as that. The whole thing, alright, is u. So u is 5x to the 4th minus 2. Always look for that. Substitution. du, alright, let's see what that is. 5 times 4 is 20. X to the third. Remember this derivative of 2 is 0. So 20x to the third dx. Well, look at this very carefully. I have x to the third dx. Now what's standing in the way of it? That's right, the 20. So if I multiply by 1 over 20 on both sides, some people divide by 20, that's okay. Alright, so what I have here is 1 over 20 du is equal to now x cubed dx. So I have that taken care of right here. And so now I just have to put the 1 over 20 right here. 1 over 20. Alright, there we go. Now u. U is all of this. Okay. Alright, so u to the 6th power du. And I think once you start seeing that pattern, it starts looking so much easier. Okay. My light blinks so slowly, sometimes I wonder if it stops on I have a camera set up here, and if that light stays red and doesn't blink, that means my video's done. But it's still blinking, so we're good to go. Alright, so 1/20. Okay, so now look here. U to the 7th over 7. Alright. Oh, well, we could put plus c. Doesn't matter where we put it anyway, plus c. Okay. Now, let's see. I'm going to multiply 20 times 7. 2 times 7, 14. So this is equal to 1 over 140. Alright. U to the 7 plus c. Okay, you can just put it all together like that. Okay, so now u to the 7th power is, so 1 over 140 times 5x to the 4th, 5x to the 4th, minus 2 to the 7th power plus c. In this particular case, we do not know what c is. We don't have what we call an initial condition, okay? Like passing through 1 comma 2, or say f at 1 equals 2, or something like that. We don't have that. So anyway, we're not looking for c. We're still just doing substitution. I know I did that in my last video, but we're not doing that in this video. Okay. Alright, there's that problem. Alright, so again, let u, look for the exponent that's 1 higher, and let u be that. The whole thing. Not to the 6th power. Just that. Okay? Alright, so here we go. Alright, I'm going to erase this, and we'll do, I think I have one more problem. And then next video, in my next video, I plan on doing trig functions. I don't think I have a trig function yet, so right now, and probably will have some e to the x or whatever, and so that's kind of why I want to do 3 different lessons. Okay, let's do one more. So here we go. Sometimes it comes in quotient form. Alright, so I've got x squared plus 2 over x cubed plus 6x minus 1 dx. Alright, question to you. What am I going to let be u? U is the one that has the bigger exponent in it. One bigger. Okay, that's the key. Alright. Because when we take the derivative of this, we want this x squared plus 2 dx back, don't we? We want that. Alright, so we're going to let u. Let's get a different color. I don't know. We'll find something. Here we go. Let u. We're going to let it be x cubed plus 6x minus 1. Now du, now watch this, is equal to 3x squared plus 6 dx. Now it would be nice if this were 3x squared plus 6. But it's only x squared plus 2. But look here, we can, but KP the math G, can I not factor out a 3? You most certainly can. So if I take out a 3, right here, and divide this by 3, alright, so x squared, 6 divided by 3 is 2, dx. Oh, this is so nice to be able to see that, right? So that just means that, you know, if I can multiply both sides by 1/3 and get rid of that 3, so 1/3, okay, that's gone now. And so 1/3 du, or du over 3, whatever you want to do, is equal to x squared, yeah, plus 2 dx. And isn't that what I have here? I have all of this right here. That's what I have, don't I? That's pretty nice. So now let's go ahead and do this. And maybe we'll see what's going on here. Well, let's see. I've got, let's see. Trying to think what I've got to do here. Let's see. This is u on the bottom. Oh yeah, I got my 1/3 that I need to put out here. And my du is all of this. Alright. Well, oh good. That's good. I like seeing that. Okay. Because I know that du over u, what is that integral? Remember? If I do, and actually you can say, if you want to, 1/3. Say some of you may recognize it this way. Alright, either way, what is that? Yeah, that's right, ln, right? It's the ln. Okay, so it's 1/3 ln of u. Absolute value borrowed, I don't know. Let's see. Now, only thing to do now is to substitute what I let u be. It's all of this, and sometimes you might get used to just plugging that in right away. Alright, so okay, so equals 1/3 ln of u. Alright, so x cubed plus 6x minus 1, okay, plus c. If I knew for a fact that this could never be negative, let's say like x squared, okay, like that. If it just had x squared or x squared plus 1, then I wouldn't need the parentheses around that. But I mean, at absolute value, I mean around that. So I'm just saying, I don't know about that. So anyway, I'm going to put the bars around, and I may just look that up and see if I need to have those or not. But some people put them there, and I'm going to put them there for now. Well, that's what we have to do. So in summary, you have to look, when do you know to use and for polynomials, when do you know that you need to use the substitution method? You have an exponent that is one more than this. This becomes your u, and you want du to come out like this. If it doesn't, well, we got to do something else. Okay, but it does, in these cases it will. We did have a 3 times that. We just have to factor that 3 out, and there it is. It's hidden in there. So multiply by 1/3 to get rid of that 3 there, and you are left with x squared plus 2 dx. That is du. 1/3 du, but I put the 1/3 on the outside. Okay, and then once you integrate this, don't forget, you can't leave it like this. Put this back in there. Okay. Alright, so, and there will be a different method when we do what we call definite intervals. Alright, intervals. So right now we're doing the indefinite because we don't have, well, we have to have a plus c on the end like this. Okay, anyway, there is a difference there. Alright, and then once again on this other side, since I don't think I erased it, we still did this. The u was this. Du is something in the form of x dx. Well, it was 8, so we multiplied by 1/8. Okay? So keep that kind of stuff in mind when okay, is this one that we can do by substitution? And in this case, yes, that is. Okay. Alright, that ends the lesson for today. That's part 1. We'll do another part later. This is KP the Math G. Don't forget to click that subscribe button. Alright. I've got a few subscribers so far. Not a whole lot right now, but I'm hoping for more. And if you have a comment on this, please do comment. Perhaps maybe you have a better method and you want to show it to me or share it with me. Or perhaps maybe you say, hey, good job. But anyway, make a comment. If you do make a comment, make something constructive where I can, even if it is a little negative, that, something that I could use to help me get better. Alright, that's KP the Math G signing out. I hope that you do have a wonderful, wonderful day. Have a nice day.